sometimes all the reactant will be converted to the product, so there will be no change of the conductance. Okay, so suppose initial is 5000, the final is 2000. So what is the halfway point? That means the difference is 3000 and halfway will be 3500 around. Suppose it is this or whatever it is this. Okay, so the time needed to go to that point, that means here it can be 5 minutes, 10 minutes, whatever, that is the half-life time of the reaction. Okay, so with the help of these we will try to find out the half-life time of the reaction. And what is the rate constant? We know that any rate is directly proportional to the concentration of the reactant, right? So these are the two reactant, and the power of the stoichiometry, like since these are the 1:1, so the power is 1:1. The acetate ion, sodium hydroxide ion and ethyl acetate, the concentration of the sodium hydroxide and concentration of the ethyl acetate. So it is a second order reaction. If it depends on if the reaction rate is depending on the concentration of the two reactant, then it's called a second order reaction. So what is the rate constant? This is rate, and rate constant is actually the proportional constant K. Okay, K of this one and this. Okay, so we are going to find out the K, rate constant. Okay, but the thing is that this is a second order reaction, but for our the calculation for the second order reaction is very hard. Even to do the experimental part, it's very complicated. So that's why we are going to convert the reaction to the first order reaction. How? So we can convert it to the first order reaction if we give a very excess amount of one reactant. That means what we will do in our lab, we will add sodium hydroxide in very excess amount. Okay, so that the change of the concentration of this will be insignificant. Okay, so if the change of the concentration of one is insignificant, then it will be a first order reaction. Okay, so we will convert the second order reaction to the first order reaction for this. Okay, and we will also find out the activation energy. Okay, you know what is the activation energy? What is the activation energy? This is the minimum amount of energy what the reactant should have to convert to the product. Suppose normally the activation energy curve look like this. So this is called the activation energy. Okay, so all the reactants should go to above this curve to form the product. Okay, so with the increasing of the temperature, what will happen? The collision of the reactant will be increased, so much number of reactant will go to the convert to the product, but the activation energy will remain same. Okay, but the number of the product will be increased with the increasing of the temperature, with the increasing of the, and with the change of the catalyst and some other factor, pressure. Okay, and for the rate constant, this K is also varies with the temperature. Okay, you will see that. So now come to this is the I am explaining what we are going to find out from this lab. So ethyl acetate and sodium hydroxide, this is called the basic hydrolysis. So there are some acidic hydrolysis, this is the basic hydrolysis. So what's going to happen? This is the ethyl acetate and sodium hydroxide. These two are going to form the sodium acetate and alcohol. Okay, so as you know, the conductivity, what forms the conductivity? What is responsible for the conductivity? The conductivity actually the ions are responsible for the conductivity, right? So among these two, which has the ions? Does it have any ions? No, it doesn't form any ions. Okay, so it will not give any conductance for this reaction. But sodium hydroxide, this is an ionic compound. It has the sodium ion as well as the hydroxide ion, right? So both of them are responsible for the conductance. Okay, and again this is also a ionic compound, the sodium acetate, minus and plus. This will also take part in the conductance, but this will not take part in the conductance. Okay, so at any stage, if we try to find out the specific conductance will definitely depends on the concentration of the sodium ion, right? Concentration of the sodium ion and the molar conductivity of the sodium ion. This molar conductivity depends on the, basically depends on the particle